Every year, millions of lives are silently shaped by a global epidemic, one that affects not just individuals, but entire communities, economies, and futures. Obesity, it is more than just a number on a scale. It's a complex, multifaceted issue tied to health, lifestyle, and opportunity. Consider this. The World Health Organization estimates that over 1 billion people worldwide are living with obesity. 650 million adults, 340 million adolescents, and 39 million children. By 2030, if trends continue, nearly 1 in 5 adults globally will be affected. This is not just about appearance, it's about health. Obesity increases the risk of chronic diseases like diabetes, cancers, and heart disease. It contributes to 4.7 million deaths annually, more than smoking. And the economic burden? Over $2 trillion each year, equivalent to the GDP of a small nation. But it's not just about the numbers. Behind every statistic is a person, a story, and an opportunity to change the future. Through data, we can uncover insights, track trends, and create solutions to combat this global challenge. Hello, Assalamualaikum warahmatullahi wabarakatuh, and a very good day. Today we are going to present our statistics mini group project entitled Obesity Analysis. What are the risk factors associated with obesity? So the presenters are Siti Aisyah Harun, SHIN, SYABILA, SHAMSUL, and TAMEEMA NOWSHIN. For the context of this presentation, it starts with what is obesity, the data sets, descriptive analysis, hypothesis testing, correlation analysis, and conclusion. Moving on to the definition of obesity. Obesity is a long-term progress that tends to happen when a person who has no balance in their diet and physical activity, the number of calories taken, are exceeding the number of calories should burn. According to Center for Disease Control and Prevention, CDC, obesity can drag other serious diseases such as diabetes type 2, heart disease, and cancer. And of course, statistics from WHO stated that 8% of children and adolescents in 2022 were living in obesity. Approximately 160 million young people were affected. What are the indicators on how to measure an obese person? Measuring obesity, BMI, body mass index, is a common way to measure obesity. BMI is weight divided by height squared. A BMI of 25 to 29.9 is in the overweight range. A BMI of 30 to 39.9 is in the obese range. A BMI of 40 or above is in the severely obese range. Moving on to the first objective, which is to summarize the population's demographics by analyzing the distribution, variability, and central tendency of age, height, and weight, as well as the frequency patterns of obesity levels, obesity, and frequent consumption of high-calorie foods, FAVC, using descriptive statistics and bar charts. Next, the second objective is to analyze whether the distribution of obesity level and weight across gender are inequality. The third one is to investigate the relationship between height and weight. And for the fourth one, the objective is to investigate the relationship between the frequent consumption of high-calorie food, FAVC, and obesity levels, obesity, to determine if infrequent consumption is associated with higher obesity levels.
Next we will look into datasets used for this analysis. The original data titled Prediction of Obesity Levels Based on Eating Habits and Physical Activity from Kaggle website. The dataset contains 2,111 rows of data and 17 variables, with 5 quantitative data and 12 qualitative data.
The figures shows the metadata tables of variable names with the description and the category of data.
Hello, I am NOWSHIN. We will start by understanding the basics of descriptive statistics. Descriptive statistics refers to a set of methods used to summarize and describe the main features of a dataset, such as its central tendency, variability, and distribution. The primary objective of descriptive statistics is to effectively summarize and describe the main features of a dataset, providing an overview of the data and helping to identify patterns and relationships within it. Descriptive statistics provide a useful starting point for analyzing data, as they can help to identify outliers, summarize key characteristics of the data, and inform the selection of appropriate statistical methods for further analysis. Objective 1. To summarize the population's demographics by analyzing the distribution, variability, and central tendency of age, height, and weight, as well as the frequency patterns of obesity levels, obesity, and frequent consumption of high-calorie foods, FAVC, using descriptive statistics and bar charts. Descriptive analysis on quantitative data. In order to give a comprehensive understanding of the demographics of the populations, Objective 1 emphasizes on demonstrating the quantitative variables of age, height, and weight. Frequency distribution of BINTI data. Age. The population is categorized into 3 groups, based on the BINTI age data: young, middle age, and old. The young age group has 2,028 individuals out of 2,111, which is the highest frequency compared to the other 2 groups. The old age group has the lowest frequency, which is 10. Frequency distribution of BINTI data. Height. The concentration of people around average adult heights is shown by the BINTI height data, which divides people into different ranges. In less than 1.50, the short height individuals are presented with the frequency 9 individual and the percentage is 0.4. The 1.60 to 1.69 meters, 33.9%, and 1.70-1.79 meters, 37%, ranges have the highest frequency range, which are 716 and 781. It shows that the majority of people are within normal adult height limits. Frequency distribution of BINTI data. Weight. The BINTI weight data shows an important variety of weight distribution of the population. From 74.60 to 99.19 kilograms, 31.9%, has the highest frequency range, which is 674. The second and third highest range is 99.20 to 123.79 kilograms, 26.8%. And 50.00, 74.59, 26.8%. Here these 2 ranges have 566 and 565 individuals. The lowest range is 148.40 plus kg, 1.1%, and the frequency level is 24. Here, most of the people are under high weight. That's why the larger number of obesity cases in the statistics may be due to the fact that many people belong to the larger weight categories. Descriptive statistics for age, height, weight. The table showing the mean, median, standard deviation, minimum and maximum for age, height and weight. Age. The population's mean age is 24.31 years, with a median age 22.78 years, and its standard deviation is 6.346. The lowest age is 14 years, while the highest age is 61 years, showing a relatively young population. Height. The height mean is 1.70 meters, median 1.70 meters, and the standard deviation is 0.093 meters. The minimum height is 1.45 meters, and the maximum is 1.98 meters. Weight. The weight of the mean is 86.59 kilograms, median is 83.00 kilograms, and the standard deviation is 26.191 kilograms. The minimum weight is 39.00 kilograms, and the maximum is 173.00 kilograms. Histogram for age. The histogram for age shows that most people in the population are young, with a higher concentration of people in the lower age range. There are 28 young people, 73 middle age, and 10 old people. These three categories indicate that, as people become older, the frequency dramatically declines and narrows down toward the senior age groups. This distribution is basically pointing out that the sample is primarily composed of younger people, with very few senior age groups included. Histogram for height. The height histogram illustrates that the majority of people are dispersed in the 1.60 to 1.79 meters mid-height range, 716 and 781 people, which is the most typical height range in the population. Fewer people fall outside of this range, with very few being lower than 1.50 meters or taller over 1.90 meters. The mid-height pinnacle shows that most people belong to the average height for adults, with little variance on either side. Histogram for weight. Compared to height, the weight histogram has a wider variation, indicating greater population diversity. The majority of people, 674, 566, 1420, are between the slightly healthy to overweight ranges of 74.60 and 123.79 kilograms, which correspond to most adults. People weighing less than 50 kilograms or more than 123.80 kilograms show a visible decline in frequency, 140.24, suggesting that these weight ranges are less typical. Descriptive analysis on qualitative data. The purpose of Objective 1 is to describe the qualitative variables of obesity levels, obesity, and frequent consumption of high-calorie foods, FAVC, in order to comprehend demographic trends connected to behavior and health. Analysis for eating high-calorie foods frequently, FAVC. The frequency table and bar chart depicts the distribution of reactions to frequent eating of high-calorie food, FAVC. The dataset has two categories: yes, eat frequently, and no, does not eat frequently. In the frequency column, it shows that, under yes, 1,866 people, or the majority of the people, 88.4%, reported regularly consuming foods that are high in calories, and under no, a lower percentage of respondents, 11.6% or 245 people, don't usually eat items which are high in calories. Bar chart. The bar chart illustrates the significant difference between the two groups yes and no. The number of people, 1866, who eat high-calorie foods is higher than people, 245, who doesn't eat high-calorie foods. Analysis for obesity level. The frequency table and bar chart shows the distribution of obesity levels, and the categories are underweight, normal weight, overweight level 1, overweight level 2, obesity type 1, obesity type 2, and obesity type 3. In the frequency column, it shows that obesity type 1 has the highest frequency, which is 351, 16.6%, and the lowest frequency is 272, 12.9%, which is underweight. Overweight level 1 and overweight level 2 share the same frequency, which are 290, 13.7%, and 290, 13.7%. The bar chart. The bar chart illustrates that the obesity 1, 2, and 3 categories groups have higher frequency, which are 391, 297 and 324 than compared to other groups. Next, I'll be discussing on the statistical inferences, which is the hypothesis testing. Hypothesis testing involves formulating a claim about the population and testing the claim by analysis of the sample data, in which including the one-tail test and two-tail test. Hypothesis testing is used to achieve the Objective 2, which is to analyze whether the distribution of obesity levels and weight across gender are in equality. For the hypothesis testing on the qualitative data, which is the obesity level, which has been divided into 7 categories, which are the underweight, normal weight, overweight level 1, overweight level 2, obesity type 1, obesity type 2, and obesity type 3. The hypothesis statement that has been formulated are: the null hypothesis is, the categories of underweight, normal weight, overweight level 1, overweight level 2, obesity type 1, obesity type 2, and obesity type 3 are in equal probability from the study population. Meanwhile, the alternative hypothesis is the categories of underweight, normal weight, overweight level 1, overweight level 2, obesity type 1, obesity type 2, and obesity type 3 are not in equal probability from the study population. By using the chi-square test with 95% confidence interval, since the p-value of the chi-square test is 0.026, which is smaller than the alpha value which is 0.05, hence, null hypothesis is rejected. Therefore, there is insufficient evidence to support the claim that the categories of underweight, normal weight, overweight level 1, overweight level 2, obesity type 1, obesity type 2, and obesity type 3 are in equal probability from the study population. Based on the clustered column chart, it can be seen that all 7 obesity categories are not having the same probability. Since the value of n is equal to 2111, and there are 7 categories of obesity level, thus, there should be 301.6 individuals, which is equivalent to 302 individuals should exist in each category in order to prove the claim that there is an equal probability of obesity level category among the study population. Based on the clustered column chart, it can be seen that the individual with obesity type 1 has the highest frequency in the study population, which is 351, while the least frequency are among the underweight individuals which is 272. In order to achieve Objective 2, a normality test is firstly carried out with 95% confidence interval. This is because the variable that is used is the quantitative data, which is the weight. This is to determine whether parametric test or non-parametric test is needed to be used to test the variables. The null hypothesis for the normality test is the data is normally distributed, while the alternative hypothesis is the data is not normally distributed. The mean, median, and mode must be equal for normally distributed data. Based on descriptive of weight, the mean of the weight is 86.59 kilograms, while the median is 83 kilograms, showing that the mean and median of the weight are not equal. Since n value is 2111, which is more than 50, thus, Kolmogorov-Smirnov result is used. The p-value is 0.001, which is smaller than the alpha value, which is 0.05, hence, null hypothesis is rejected. Therefore, the data is not normally distributed. Hence, a non-parametric test is carried out. The histogram and normal QQ plot also show that the weight is not normally distributed. There exists outliers in the data of weight where the maximum weight is 173 kilograms, while the minimum weight is 39 kilograms. After determining that non-parametric test is needed to be carried out, then, hypothesis statement is formulated. The null hypothesis is the weight between males and females are equal in the study population, while the alternative hypothesis is the weight between males and females are not equal in the study population. By using the Mann-Whitney test with 95% confidence interval, since the p-value is 0.001, which is smaller than the alpha value, 0.05, hence, null hypothesis is rejected, there is insufficient evidence to claim that the weight between males and females are equal in the study population. According to this back-to-back histogram of weight across gender, there are 1,043 females and 1,068 males in the study population. The mean rank of males, which is 1,179.19, is higher than the females, which is 929.85, indicating the weight of males in the study population is higher than the females. The histogram in the weight of females is also more spread out than the males, also indicating that the weight between males and females is different. Thus, after performing the chi-square test and Mann-Whitney test, both using 95% confidence interval, it can be concluded that the distribution of obesity levels in the study population are not an equal probability, while the weight of male and female are also not equal in the study population.
Next, Objectives 3 and 4 focus on statistical inferences, specifically using correlation analysis.
Objective 3 is to investigate the relationship between height and weight. Since both are quantitative variables, we will analyze their relationship using correlation analysis for quantitative data. The figure displays a scatter plot of height and weight, showing a positive linear relationship. This indicates that taller individuals tend to have higher weights. However, the data exhibits a heteroscedasticity pattern, suggesting that it is non-parametric. The next step involves performing the Spearman-Rho correlation, as the scatter plot indicates a heteroscedasticity pattern for the variables height and weight. Hypothesis testing for correlation significance. Null hypothesis is equal to there is no correlation between the variables. Meanwhile, alternative hypothesis equal to a correlation exists between the variables. As shown in figure, the p-value is less than 0.001, which is smaller than the significance level where alpha value is 0.05. Therefore, we reject null hypothesis, indicating a significant correlation between height, in meters, and weight, in kilograms. The Spearman-Rank correlation is 0.463, suggesting a moderate positive relationship between height and weight in this dataset. Next, objective 4 is to investigate the relationship between the frequent consumption of high-calorie food, FAVC, and obesity levels, obesity, to determine if frequent consumption is associated with higher obesity levels. Objective 4 indicates the correlation between FAVC with obesity, in which both variables are qualitative data. Before starting the analysis, the variables categories must be identified to determine the rows and columns for the analysis. This will help decide which types of measurements to use for the correlation. From the crosstab figure, the variable for FAVC and obesity levels is more than a 2x2 contingency table. The contingency table for this correlation is 7x2, which means Kramer's V will be used to conduct the correlation analysis between qualitative variables. Next, we need to conduct a chi-square test to confirm significance. Hypothesis test for testing the correlation significance. Null hypothesis is equal to there is no correlation between variables, while for alternative hypothesis is equal to there exists a correlation between variable. Based on figure, the significance value is less than 0.001, which is smaller than the alpha value, 0.05, hence, H null is rejected. This indicates that there is a significant correlation between the frequency of eating high-caloric food, FAVC, and the obesity level category. Then we can measure the FAVC and obesity level relationship. As the contingency table for these variables is more than 2x2, thus Kramer's V value will be used to interpret the correlation. The Kramer's V value for the correlation is 0.332, which suggests that the strength of the relationship between FAVC and obesity level is very strong.
In conclusion, this study successfully met its objectives by analyzing the factors associated with obesity through descriptive, hypothesis testing, and correlation analysis. These results strengthen the importance of deep understanding demographic and behavioral influences on obesity to inform preventive measures and health interventions. Also, future work could expand by incorporating more comprehensive variables such as cultural or ethnicity to better understand obesity's multifaceted nature. In addition, interventions focusing on personalized lifestyle changes and broader public health strategies could further mitigate the growing obesity epidemic.